Well, it's a real pleasure for me to have the opportunity to welcome Jack Kaye and introduce you to Jack. Um, the first most important thing is, as of April, he retired after a 42-year career with NASA. So congratulations to Jack. That's a great thing. We'll hear about Jack.
41, but close enough.
Some of the internet rounds up to 42. So Jack was born in Brooklyn, New York. You might have heard of it. And then his family took him to Nassau County in Melbourne, where he spent his formative years as a Long Islander. He sort of quotes Billy Joel to prove that he's a Long Islander. Jack did a BS in chemistry. I have a lot in common with Jack. If you go to the internet, you find that not only is he a chemist, but he loves wearing ties. In fact, according to the article I read that he showed me, he started wearing ties when he was a kindergartner. So I really like that. Jack has good fashion sense. So he did a BS in chemistry at Adelphi, then a PhD as a hardcore physical chemist doing quantum chemistry and kinetics, that sort of thing. So most recently, he spent 20 years as associate director for research in the Earth Sciences Division at NASA, as a member of the SES, the Senior Executive Service. So it means he was a fungible civil servant in Washington, D.C. Jack knows an awful lot about federal agencies doing science. So we have a great opportunity to hear from him today, and you can interrupt him as he's talking and asking questions that knock him off his game. But he's a civilian now, so he can say whatever he wants, and your job is to get him to do that. Much of Jack's work has been about satellite-based observations and making sure we understand those, sometimes with aircraft supporting observations, looking at key constituents of the Earth's atmosphere, like stratospheric ozone. I think a personal highlight for him is working on the Atlas series of space shuttle missions, where he played a key role in coordinating and managing the science carried out by people from around the world, maybe on the order of a dozen instruments from scientists from different countries. That would have been a thrill. Prior to this job as associate director, he served for 10 years as manager of the atmospheric chemistry modeling and analysis program. And before that, in the early part of his career, he was a space scientist. That's a cool title. You want to be called space scientist. He has a ton of awards and honors. Among them is he received the NASA Distinguished Service Medal in 2022. He's a fellow of AAAS, the Advancement One, and also of the American Meteorological Society. And he is a candidate for president of the American Meteorological Society. So Jack is going to work hard to completely fail at retirement. He's on track for that. Anyway, as I said, he's a civilian. He ought to be able to say whatever he thinks. And I urge you to ask him the tough questions, which we'll hear the answers to if I stop talking. Turn it over to Jack. So, wow.
And just,
Yep, just click it.
okay, hopefully that's,
Yeah.
that's working now. The thing is, never give a theorist equipment. Nothing good can come out of that, but hopefully that'll work. If not, somebody will say, I think, assume people will say, we can't, So I'll try to move around a little bit. get me the quicker to do this. So that's a real privilege to be here. I'd say to be here at SUNY Stony Brook, but I suspect if I say SUNY that some AI client will terminate the Zoom and, terminate things. So I know that I'm not supposed to say that. So I guess I do what I'm supposed to do, say Stony Brook University, but to say as a native Long Islander, it's still SUNY to me. Let's see, this may have to.
Oh, wait.
The first time on the.
Oh, okay.
Slide.
Can you spec louder, please?
That's excellent. Usually it's, okay.
I want you to yell at them, Jack.
Let's see.
There you
Yep. All right, so what I'm gonna do is just a little introduction and talk about integration, because while I was running the research program for NASA Earth Science, a big part of my job was to help, not just to have the research piece, but to make our research piece play well and be sort of mutually supportive with other parts of NASA, other partners, and even within that, to make sure that we're integrating vantage points, we're integrating approaches and techniques, integrating programs and integrating communities. So as I said, it's Long Islander, I thought just Paul talked a little bit about it, but to show my Long Island roots and some of the places that were important to me and so where I am today, and also had the privilege of looking down on Long Island not too long ago during the stacks campaign or Roma stacks, but the stacks part of it brought for the G3 and got to look more at Nassau County from that part of it, but so got to see it from the ground and got to see it from the air. So by way of introduction, want to say that there's a couple of things that are really important to think about when you think about Earth science at NASA. One is that it's a very special place in terms of the integration of science, space and aeronautics and serving society, and that's unusual. If you think about other programs, agencies, and other space agencies, even they'll be making places that do the science but don't do the space, or do the space but don't do the science, or do the space and the science but don't really do the societal things. So it's a pretty unique environment that we found ourselves in. The NASA Earth Science is also an end-to-end organization going from technology, spaceflight, data systems, research and applications or action. And again, that end-to-end aspect is something that's very different from a lot of the other agencies that do these sort of things. They may do the space, but not the technology, or they may do the science, but not the space or whatever. So that end-to-end aspect gave us a capability, but that meant if you had different parts of the program, we needed to make sure that there is a collective synergy. And finally, NASA funded both the intramurally through the centers and extramurally, especially at universities, but also laboratories of other government agencies and private and nonprofit. And a lot of the enabling capability that underpinned what the whole community did was done out of the NASA centers. So those are some things that are really important to think about in terms of how we try to accomplish what we were doing. So I'll start out with integration of vantage points. And my guess is, no offense, but there's probably not a lot of other people from NASA who will start talking about integration of vantage points, because NASA stands for the National Aeronautics and Space Agency. So you tend to hear about space first, or in some parts aeronautics, but to me, there's a real synergy associated with doing things from space, doing things from the air, and doing things on the ground. And to remember that the vantage points are complementary and mutually supportive. And there are times in the past that you almost have a sense of, hostility may not be quite the right word, but there is a sense that, we don't need satellites, or the satellites aren't there yet, so we're just going to do our stuff from airborne. And then the people doing the satellites would be like, well, we got it from space, we got the whole planet, what do we need the other stuff for? I think we've come a long way as a community, and the surface-based measurements will do all of these things. I'm not going to read all the words, but it really provided a way, especially for going from developing the technology, testing something out in the air, getting it to the point that it's ready to fly in space, and get that stuff on the ground and get complementary, interdependent, supportive of calibration and validation, and also get stuff into space is, historically, it was far and expensive to get something into space. You want to make sure that it works, so you don't necessarily want to have people who've never done that before, doing things and going into space. But say on the ground at an airport, it's a great way for people to build their first instrument, acquire their data, write it up, get that experience, and then take it to space. So the airborne program became an important part of the training ground for the people who did the satellites in the future. So a variety of things that one needs to do that's complementary of that. So we have a satellite fleet. This is a relatively recent one. It's we call it the swirl diagram or the swoosh diagram. Oldest come here, it goes counterclockwise around the outside. Things that are would be on the space station are here. They're color coded in terms of whether they're in extended operations, prime operations, being built, or being planned. The colors may not they come out pretty well, but pretty much, it's extended operations, prime operations, being built, being planned. And then there are some things that we have on operational satellites, and we're really good, or depending on how you call it, really bad in terms of use of acronyms and abbreviations. So you'll see a lot of them. I'll probably not, try to explain all of them, but everything has names. Some names are words, some of the names are people, and some are just abbreviations that are meaningless to anybody else. But these are all things that are in space or are going into space. The budget cuts that the administration proposes for its FY26 budget would devastate this. There's a version of this that a former colleague put on the internet where he put little red X's over all the ones that would be cut off based on the administration's budget proposal. And I think there's 17 red X's on it in terms of ones that are flying now or ones that are in the process of being built. So the two lapel pins that I'm wearing, I don't usually wear two lapel pins, but both for missions that are currently operating that would be terminated in response to the administration's 26 budget. But it's a lot. There's a lot of things in the past relatively brief couple of years. There's a lot of major satellite missions that have been launched going back to, I think, the end of 22, SWAT, PACE, Tempo, NISAR, Refire, tropics, a lot of things. So, and really significant missions that are going to add to the body of Earth system knowledge, and support applications for a long time. So, well, there's really sort of very significant worries about the future. There's a lot of new data that are being generated now based on recently launched satellites. We have surface-based measurement networks, small, large. The largest one is AeroNet with for surface-based measurements of atmospheric radiation, especially for determining information about aerosols, well into the hundreds. Tropospheric goes-on LiDAR network, who's I think started out with 6, went up to about 8. They're in between. A lot of for atmospheric chemistry, some for a variety of other things. Oldest one, A gauge, measuring surface-based concentrations in situ, radiatively and chemically active source gases. I think it's like 46 years old. Network for detection of atmospheric composition change, formerly network detection of stratospheric change. Not much behind that. If you actually go through the website for NDSC, you'll find a figure from the Stony Brook, through an article in 1996 from Bob DeSafra. So Stony Brook was part of that, and a lot are. I'll skip over the details on some of them, but the point is that it's stuff on the ground. In the case of shadows, it's balloons at launch, it's passive sensing, active sensing, some are underpinning. For geology, the GLOW program is launched student measurements. SOCOM is putting biooptical instrumentation on some floats in the Southern Ocean. So, and we have the airborne science fleet. It's our own fleet of planes, but it's important to remember that when you think about airborne science at NASA, it's not just the planes. It's the planes, it's the sensors, it's the systems, it's the people and the opportunities that make NASA airborne science such a wonderful program. And again, with the proposed budget cuts, probably not going to be able to maintain all of them. The DC-8 we had for many years is a primary program, but after the Asia AQ campaign, that they got welcomed back to NASA Armstrong. I guess the way you welcome a plane on its last flight is you have weather jets, and it's now sitting on the ground at the Adelphi State University in Pocatello, helping to train a future generation of airborne scientists. The next big aircraft that we're looking to get is the B777. So that was purchased, and something that you rarely hear said about an aircraft, where it's now having holes put in it. Holes in the bottom for remote sensing, holes on the side for inlets, for in situ, because that's what you need a research aircraft to do. And the ER2 is our highest flyer. That one, probably the days are numbered because financially we leveraged the DoD U2 program, and they want to end that. So without the ER2, the WB-57 becomes our highest flyer, but it doesn't have the altitude, it doesn't have the range, and the G3s are getting old. I think we're just trying to buy a G5. But these planes give us the enormous flexibility to, and they're very different in terms of size and people, but a lot of flexibility to go where we need to go to get to where we need to get the data, whether it's for process studies, CalVal technology demonstration. And so many people really cut their teeth in this community in the airborne program. And we'll do things, especially try to get calibration and validation for satellite data, but complementary data. So just a couple of campaigns that we did, the CPEX campaigns with the DC-8. We did one year in St. Croix, and then to Cabo Verde, but with a combination of wind LiDAR, constituent LiDAR, dropsons, radars, microwave, and so you have integrating techniques. I'll come back to that a little bit. But one of the things that, as part of integrating programs, it's not just CalVal for our satellites, but we try to work with others. So a big focus of what we were trying to do there was to get correlative data for and complementary data for the European Space Agency AOLA satellite, which was a wind LiDAR, because they really did not have the capability for to do the kinds of things that we did. So we did the campaign, and we learned about the atmosphere, and you can see the very different kinds of trajectories that we would do from one flight to the next, because the atmosphere lets you do that, and but we'd have information and try to get under flights with the ESA satellites as well as SoMAS. And I mentioned Asia AQ, where we flew in the Philippines, South Korea and Thailand, and sort of did some touch and goes in Taiwan, and there were people on the ground, and 2 aircraft, a DC-8 and a G3, with a mix of in situ and remote sensing, and done the flying a variety of things, including Korea's GEMS instrument, which is the world's first geostationary air quality measuring satellite. Now we have Tempo, but Tempo was second. South Korea was first. They were also first with geostationary ocean color measurements too. And there's a lot of some things that we've been doing on the ocean side, especially in the past few years. If you go back in time, there was less in terms of sort of integrated measurements in terms of ships and other sources of in situ ocean measurements and satellites, but we've been doing that a little more of that the past couple of years, and in a variety of things. So it's neat kind of things. And I remember at one point when we started doing some others in regional management, and it's sort of like, well, we do ships, does NASA do ships? It's like we do Earth system science. 70% of the surface is covered with water, and the complementary measurements may require ship-based. So, okay, but we haven't done that much before. So you can see even with and most recently PaceMax, who undefined PACE and S-mode is a precursor for future winds and currents mission. And this is the only result that I'll show. This just feels kind of funny to do a results-free talk, but I'm a bureaucrat, and I think you all understand that if you see results, you can be pretty damn sure that I did not generate it sitting in my office. But this is an example of what happens when you try to integrate things, because it relates to the total aquarium budget in the atmosphere measured with the combination of techniques, surface in situ, from a gauge, surface column measurements, surface-based upward-looking column measurements from NDAC, and then upper stratospheric chlorine from the microwave limb sound group or the Aura satellite. So you can see before the Montreal Protocol, it would be growing. After the Montreal Protocol, it leveled out, and it's been coming down. And you see it at the surface, you see it in the column, and you see it at the top of the stratosphere. And the fact that, it's also good in the current political environment, when it's easy to get depressed, to actually remember that the ozone situation is one where the nations of the world, recognized the problem. The science was there, and the world stepped up to do it in a way that is working. It's working quite well. And having benefits not just for the ozone, but also relative to radiative forcing that would have exacerbated climate change. So when you get depressed about things and say, can the world never actually step up and protect itself? This is a case where it happened, and the science was so critical to it happening and continuing to monitor the progress on that.
Okay, Jack, can I interrupt
Sure.
on these thoughts?
Will the people be able to hear the?
Oh, yeah.
Okay.
Can you go back? So let's look at the green one with the CFCs on the top. So in the late 80s, the people with a stake in making money on selling them, people at DuPont, screamed junk science. That's when that term was first used publicly. Well, one of the first. Anyway, they screamed junk science until it was clear that were alternatives. They said, oops, we were wrong. We want to sell the alternatives and help make a greener world. They're richer as a result. And this is one of the greatest environmental success stories in history. We could have the complete analogous situation with climate change and the ability to make a fortune on solar power and so on. And we don't seem to be pulling the trigger. Well, what do you think about that? Why can't we do the same?
I mean, I mean, my own sense as a lab scientist or whatever, not a political scientist or anything like that, but relatively speaking, ozone was and CFCs were an easy problem. In part because there's a relatively small number of manufacturers. And as you say, once it became clear to the manufacturers that there were alternatives that conveniently they would be able to market, and they don't be able to be supported with a lot of the existing infrastructure, albeit with some retrofitting. They stopped opposing it, but in the end, they did step up, and you can question their motives, but dealing with fossil fuel combustion is a much harder problem in terms of the number of the number of sources and the dollars at stake, and just the fact that it's so heavily distributed. So it's a harder problem, but it's good to remember that the system can work. But people talk about wicked problems, and I would say this one's a wicked problem because it's just so hard. It's just so wrapped up into the economies. But years ago, if somebody would have said, renewable power is cheaper than fossil fuel based power, they wouldn't have said that. And even in other areas like smoking, out of the world, if you think about how smoking was just sort of part of growing up. When I was growing up, and the people who didn't smoke were a little weird, and the parents who didn't smoke were absolute anomalies. And now it's almost like, heaven forbid somebody should smoke. Where can you actually go and smoke? So societies can't respond to these hard problems, but it's hard, and this is an especially hard one. Okay, I'm going to skip over a few of these things just because in the interest of time. But the integration of approaches, I talked about vantage points, but discipline and interdisciplinary observations, active, passive observations and models, enabling capability utilizations, directing and competing efforts, principal investigative and implementation, and just a few integration across the disciplines. We talk a lot about Earth system science, and I think it's one of the things that NASA really kind of prides itself on is really being at the forefront of the creation of Earth system science as a recognized discipline, as opposed to oceanography, meteorology, geography, whatever some of it, and even in the past would be like, the atmospheric chemists and the atmospheric dynamicists were like parallel universes, and they had to have summer schools to actually try and get, atmospheric dynamics for chemists one year, and next year, atmospheric chemistry for dynamicists. We've come a long way, but there's just a certain culture that's built up, and whether it's programs at headquarters, university departments, journals, reward structures, or whatever. So, trying to encourage interdisciplinary kind of work takes some effort, because it doesn't always come naturally to people. From the point of view of headquarters management, if you can sort of hold money that's only for interdisciplinary opportunities, that makes it a lot easier. Money is a good lubricator for things like that. Or if you have solicitations that are built up that way and have a lot of money, like we do with the Earth Venture Suborbital, that supports some things that wouldn't happen otherwise. And some new instruments that come along that may, it's like, even now someone's like, well, it was for atmosphere, but it can do the land, or it was for the ocean, and it can do the land, do the atmosphere. So when you can have the same things coming out of, different things coming out of the same instrument, that provides opportunities. And in many cases, as you try to get to do more and more complicated things, you realize you can't separate them. If you're like people used to say things like, well, when you're doing an ocean column measurement, 90% of the signal is the overlying atmosphere. It's not the surface. And there's a lot of things for the land. It's like, if you don't know the aerosols, you don't necessarily know what you're looking at. If you're looking at the surface or the column. So you have to, in order to get any of it right, you have to deal with the whole picture. And sometimes we can do things like the interdisciplinary science solicitations, for 3 years, but then it's like, okay, you may say, well, we'll target a topic for 3 years, but then what? Then who's gonna, if you want to be able to rotate topics, you can't just keep doing the same thing. But if you stop, well, who's gonna want to keep funding that? So it's still a challenge, but do what you can. So like the interdisciplinary science, the last one we did was 2022. You can see the topics. Some were sort of jointly with planetary. 2019, we did some very different things. Some were small, some were big. Interestingly, the administration decided that they didn't like environmental and climate justice, so all of the awards that we did out of that one, I think, got terminated. Unfortunately, some really neat stuff. And I mentioned integration of approaches, especially in terms of wavelengths and techniques like active passive. Snow is a really good example of how you really have to marshal the full universe of techniques to go after, because there's some things that you can sort of say, one instrument, all right, that'll get me a lot of what I want, or two instruments, that'll get me a lot of what I want. Snow, I'll overstate it a little bit. My sense is, if you would go to a bunch of people who really say, we want to look at, snow with remote sensing, no unanimity on, no, this technique or that technique. It'll be like, well, we need them all. So that's really what the SNORAX tried to do, is to get, so you had a passive visible and infrared, you had, radars, you had radiometers, microwave, and different bands and different techniques, all trying to do that going out. And you had people on the ground in snow pits, trying to really think about, because if you say, let's do a snow satellite, it's probably not going to be one technique, but what's the right mix? So that was something where the integration across approaches, and in the Bioscape campaign that was done in South Africa, not too long ago, with people on the ground. So it was in the passive, it was UV visible, infrared, near infrared, thermal infrared, and you had the LiDAR, so you could really look at ecosystem structure and function. Both, people looking down and then the people on the ground, really looking at that. That was the first biodiversity based focused field campaign. that we had. So that began the integration of approaches and wavelengths in order to be able to get at what we do. And use all that to look at both current satellite data, but to think about how would we anticipate future satellite missions that we'd like to be able to do, like SPG, surface biology and geology, although, the current administration budget proposal, that one's not going to see. Integrating observations and models, in the interest of time, I probably won't say too much about that, other than, the point is that, one of the reasons why we did modeling and NASA did modeling was because of the relationship between observations and models. We used to talk about observation-driven modeling. Because you need observations to initialize models, to develop process models, and to do quantitative evaluation as well as for simulation and reanalysis. So the integration of observations and models was a big part of what we would do at NASA. And everybody, I think, who does models uses observations, but maybe in a less focused way, as opposed to really trying to apply it more broadly. And talked about enabling capability that I mentioned the airborne platforms, the surface-based measurement networks, and not just ones for chemistry, say, but things like the Space Geodesy Network that provides a terrestrial reference frame that underpins a whole variety of things. It's absolutely critical to altimetry and gravimetry, but it's used for a lot of things in terms of helping to understand sort of our place in the universe, and it becomes useful for all the satellites that NASA flies. The scientific computing that was in the Earth Science research budget back until recently, the large scale computing for all the agency, not just the Earth Science, the airborne fleets, the instruments, and the models. So those would be capability that would support the whole program, and have a variety of uses. But if you have a program that you funds both the enabling capability and the utilization of that capability, then there's this inherent tension that gets built into how do you balance, and try to optimize the investment in having capability and utilizing capability. And the extremes don't make any sense. You'd be like, you don't want to fly an airplane with no instruments. You don't want to acquire data with no analysis. But you have to figure out, constantly look at what that balance is, because one thing about enabling capability, if you lose it, you may never be able to get it back. And a lot of the capability that over the years that we developed at NASA was something that you didn't find other places, or couldn't necessarily buy commercially. So if we didn't do it ourselves, there was a sense, well, then it might not be there for the community. And directed and competed efforts. Normally, what we would do is, for a while, compete most everything through the annual ROSI solicitation. And a center scientist would have to answer to that for a lot of things, most of them to the bid as well as the community. And there's a lot of pushback coming from the agency about, why do we make our government people compete to do the work that they were hired to do? So they developed something called the ISFF Journal Scientist Funding Model. Try to say, well, okay, maybe they don't have to compete for everything, but let's be really careful about that. But they said if we're going to say you don't have to compete, so it has to be community enabling. It should be best only NASA. It should be principally sized and forward leaning, and not to be something that would increase funding at NASA centers at the expense of the broader community. And a lot of suspicion out there, and a lot of even internally at NASA, people who are a little concerned about that. But in Earth Science, where we tended to bring into that would be the surface-based measurement networks, calibration validation infrastructure, facility like airborne instruments, and so the major modeling efforts, because those are all things that the community used and weren't just there for the benefits of the people who did the work themselves. And there are some other things that people like to do. And then something else for integration that I thought is worth mentioning, and might get into some interesting discussions at the end if we have time, is so much of what we do what NASA does is based on teamwork. Well, this individual investigator work that's so critical to a lot of what we do. If you think about, field campaigns and you think about satellite projects, they're almost all team-based. It's not just one person. So, how do you create teams that are going to work effectively? And in some sense, there's two ways to do that. One is if it's a principal investigator-led activity, you let the principal investigator build the team and pick the people and then propose the whole thing all at once. And there's some advantages of doing it that way, especially if you're going to hold the PI accountable for the success of their activity. Shouldn't they be able to pick the people so that they can have confidence in the team and know that things are going to be done well? The flip side of that is that potentially creates a single point of entry, and that you're not going to be on the team that's part of a proposal unless the PI agrees for you to be there. And what does that mean about early career people? What does that mean about people from institutions that might not be perceived as elite? What does it mean about somebody says, well, he or she has a different approach to an algorithm that they would like to use? Well, they might have something to offer. I don't want somebody with different ideas on my team. So there's advantages and disadvantages. A lot of the things that we've done, a lot of the field campaigns that the program managers offer, there may be a community white paper to develop a team. There'll be a solicitation, but anyone who proposed to be part of the mission. The Earth Venture Suborbital, those are principal investigator, those were done differently. So after a couple of rounds of Earth Venture Suborbital, we changed the way we do it. We competed the topic. The 3 people could be part of the leadership team, but then competed the team membership. So there were 3 out of the 6 for Earth Venture Suborbital 4 were solicited. Rose's 24, and one of them Inspire. They've actually done selection. I think 2 of them in Rose's 25, and one HAMAC for air quality would be in Rose's 26. We changed the way of doing that, and I got a thing for impacts, which was again the Earth Venture Suborbital 2, I guess it was. I was track of all of them, but that was a PI one, and these PI ones have worked quite well, but we're trying to optimize things and change the way we do it, so we'll see how it turns out. And then integrating across programs. I'm not going to go through all of these, just in the nature of some of it is probably a little bit of what might go inside baseball. But I can come back to that if need be. I did want to say a little bit about integration with other components of NASA, because we'll think about within NASA science or Earth science, or within NASA science, but what about other parts of NASA? And there are some things historically that we did a lot, like when we were doing the atmospheric effects of aviation project, which was funded by the would not be considered like the aeronautics. There's a lot of work done with aeronautics, but there was the Office of STEM Engagement. It used to be the Office of Education, and we actually worked hard with them on something for oceans, and as part of the with the Minority University program, I guess, to do some funding for oceans, and they put in most of the money, we put a little bit of money. And then one of the things that we had done for a while and stopped and did again was with the Office of Strategic Infrastructure, which is responsible for managing the centers, near term and long term. And if you think about it, a lot of our centers are environmentally vulnerable. Some of it is when you're doing space kinds of things, you typically want it where things can blow up and you don't have to worry about it. So you've got Kennedy Space Center in Florida, you've got Wallace Flight Facility on the Eastern Shore, you've got Stenn Space Center, Michoud facility. So unique infrastructure for many years, because that's all the human spaceflight launches were done out of NASA facilities, and a lot of the rockets were launched from there. Very very sensitive to environment issues, both weather extremes and climate change. So we got together with the Office of Strategic Infrastructure, did some work for a while. We kind of backed off for a while, and we're doing it again. So you can see that there was a picture with BAMS a number of years ago, where a lot of the work is done by the scientists supported by the Earth Science Division, but very much working really closely with the people in the Office of Strategic Infrastructure that have the responsibility they're making sure that the agency can function now and in the future. So they have to look at that horizon, longer term horizon, and, why not make sure that they're working with, the NASA scientists, who have the knowledge of some knowledge about how things are likely to evolve. And then interagencies, you think about earth science, and this is one of the things that's a little different from, not completely, but in degree, NASA earth science versus some of the other areas of NASA science, because for a lot of things like astrophysics, planetary science, say, once you get beyond NASA and National Science Foundation, it thins out, not completely. Like the Department of Energy is really interested, I think, in dark matter, so they would be involved in some things. But not a lot of other agencies within the federal government that were working in those other areas. Heliophysics was a little bit more science-like because of space weather, where they have to worry about the impacts of growing gas ejections and solar storms and what that can do for telecommunications and like the electricity grid things. So satellite operations. So that's a little more, but of science, that there's so many other agencies that are involved in making measurements and making predictions about the Earth system, trying to understand how it works. So it could be, bilateral, like in terms of surface monitoring networks or field campaigns. If you think about it, so many of the campaigns that NASA has done involves interagency partners in a significant way. And the modeling works to be that way to transcend for data assimilation. And then some are formal, multilateral, some by statute, some by executive direction, some temporary, some long-term. And the administration changes, that can change as well. There'll be some where if it's tied to an executive order, new administration can come in, the executive order can change. So like if you look at the executive order related to oceans, between the Obama administration and the first Trump administration, there are a lot of differences. You have to sort of know to look for them. Whether we think like, the preface eco was all over, the Obama one, I remember, not so much there in the Trump one. Trump one was very much focused on sort of resource extraction from the oceans and growing the ocean economy, worthy goals, whereas Obama had a lot about oceans and climate that was not there in the Trump one. If the new Trump administration has issued executive order for oceans, I haven't seen it. The US Global Change Research Program, it goes back to the Global Change Research Act of 1990. I think really initiated under the Reagan administration and signed into law under the George H.W. Bush administration. During the George W. Bush administration, it became the Climate Change Science Program, having to do assessments every few years. This administration basically put that on hold. So I think the websites are gone and the support contract went away. So that's in a different situation, but that was responsible for the National Climate Assessment. And there's a whole host of things for weather. For many years, you had the OFCM, the Office of the Federal Coordinator for Meteorology, or the full name, Office of the Federal Coordinator for Meteorological Services and Supporting Research. There was a weather bill a number of years ago that said to create ICAWS, the Interagency Council Advancing Weather Services, under the Trump administration and its first Trump administration. Decision was to make it the ICAMS, Interagency Council to Advance Meteorological Services. So that existed. I told that one sort of maybe starting to come back, but a lot of these other interagency things right now are kind of on hold. Headquarters staff spend a lot of time on these things. NASA scientists spend a lot of time on these things, and the investigator community spends a lot of time on these things. Some of them will be because they'll say, let's have the budget cost cut. Sounds like a very reasonable thing to do, because someone will say, how much does the government spend on something? We'll say, we should be able to answer that question across the agencies. But you start trying to answer them, it gets hard. Like if someone says, how much do we spend on the audit? Well, at NASA, we have satellites that, most of the polar orbiting satellites, they're over the orbit 15 times a day. You try and break out what fraction of, say, the cost of an operating satellite goes for the orbit. do area weighted, you know, try to do that, so it sounds easy until you try and do it. And so if someone says, what are you spending on oceans? And, you know, so it'd be something like, well, that's what we'll do, a lot of, you know, seasurface temperature, do these other things, but lots of land things, so. You can try and do that, but they're hard. As I said, let's have a plan of goals and objectives, and then we track status every year. So like, IR, the agency, or the Research and Policy Council, for a while, had something, and it's like, we did it to ourselves, and so let's create this monster of all these goals and objectives and specific tasks, and each agency, you know, which we want to be the lead on this, and we'll just be a participant, and then each year we have to report on progress. So there's some overhead associated with these things, but you know, we need to work together. We should work together. And from the point of view of the taxpayers, you know, they don't, most of them don't care. You know, to us, you know, does NASA do something? Does NOAA do something? Does NSF do something? Does DOE do something? You know, that's really important to us because that's how it gets done. But you know, sometimes I say to the taxpayers, we're just a bunch of 4-letter words or 3-letter words, you know, for NSF, DOE or something. They don't care. It's just a government. So you know, working together is really important, but you know, it comes with a price. And it used to be that earth science was separate from space science at NASA. And when we merged together, in the early aughts, I guess, I think that was one of the things the space science people couldn't quite understand. It's like, hey, why are there so many earth science people? Why do they spend so much time in interagency meetings? And the answer is because we need to coordinate. In the interest of time, I'll skip that. And just a few things on communities. I talked about cross-disciplinary integration, and well, I did it very much with the framework of Earth system science. You know, one of the things that we've learned as we think about the Earth system and trying to understand the relationship between what the Earth does to itself and what humans are doing. If you're going to bring in humans, you got to think about social science, which is not something that comes naturally to a lot of us. Some of our programs have specifically done that, like our land cover land use change program. Explicitly, we build that in because, you know, you really cannot understand land cover change or think about how it's going to change in the future if you don't think about people in terms of economics and politics and things like that. And sometimes it's hard just to figure out how to have conversations. So you try to invest in places that would help do that, like the Aspen Global Change Institute, where people can come together and have conversations that they would not otherwise have. And scenario where interagency coordination can be very helpful, because in many cases, those agencies, they have connections with users and their communities in ways that we do not, so they can help us. And I wanted to say something about, you know, participation, because it's easy to organize a program which is sort of you know, overstated as the rich get richer, but you know, the people who are at the institutions, they have a lot of work training people. But what about, you know, early career people? So we have an early career program. And one of the things that I wanted to highlight was a one research program that we've been doing for 15 years, doing it in California for pretty much all of those years. But we would brag about it. Management said, if it's so big, make it bigger. Said, well, we can't make it bigger, but we'll try to replicate it in the East Coast. So we did that. So we have SARP and SARP East. So it involves students going onto the planes, making measurements, people on the ground doing complementary measurements. Typically about 30, it was about 25 to 30 people a year, and now we can almost double it. This only goes through 24, it doesn't list 25, but colleges and universities all over the country, and really trying to get institutional diversity as a big function of that. So it's not just our one research universities, but getting a lot of people from undergraduate institutions or the institutions that, you know, because a lot of places, there's no opportunity to do this kind of research, you know, except in a relatively limited number of places. And a lot of the alumni have come back to participate. And then we try to expand the surface-based measurements by doing IPMSI, improving participation of minority serving institutions. So we did that with atmospheric, chemistry, physics, and precipitation. And you can see where we did that with the first solicitation, and, I guess, I think that they were all in pretty good shape. Stony Brook stole the PI from Spelman College, so that's still working, and the idea was positive, so, they did it again in Roses 24 specifically to add that to carbon measurements, so I think those instruments have all been ordered, and, again, you see a variety of, the things that have been done to really bring new people in, and institutions and faculty and collect data, so, I'll skip over some other things, so, by way of concluding, why integration? The challenges of climbing global change are bigger than what anybody can do. If you're gonna make it work, you gotta work together in every way. I think that we have done that at NASA, Earth Science. That kind of integration doesn't always come naturally. So it means that from a management point of view, attention, focus, resources, reward mechanism, external communication need to go into how do you make that integration work and last, so that everybody, is part of the integration. Sometimes it's hard, people want to talk about what they do, not what the whole community is doing, but that's what matters. And the current budget uncertainty complicates near-term planning. That uncertainty is there for NASA, it's there for interagency partners, and that means it's there for the investigative community. And, I think historically NASA has really tried to take really seriously, the concerns of the investigative community, because we know, especially when there's uncertainty, it's those at the most vulnerable stages of their career, who are most likely to be impacted. So grad students, the postdocs, the soft money people, and that's a tenure track path. Because when impacts come, we know it's people's, careers, it's people's jobs, it's people's careers, and that means it's their family lives that are at risk here. So we think about it not just as a matter of science, but as a matter of really trying to think about the implications for people. So, okay, I talked too long, I'll stop.
Thank you so much. So we have two students that will pick off the Q&A, Anushka and Ali.
Hi, thank you so much for your presentation. It was really great, and I know that currently NASA is facing likely massive cuts, and you were talking about how that affects the satellite program, and also how that would affect the Airworks program and what planes you guys are able to put out. And I was wondering, who would be deciding which satellites get cut, or which planes might get cut and not be able to operate? Is that kind of out of NASA's control? Is that in terms of the people just coming in slashing the budget, or how are those decisions being made and kind of all put in?
Okay, I walked over here, wanted to try to make sure that people, is in the room, and that's online, in the question. Some of those things could be dictated by the administration of the budget proposal. And some may just be, you got this much money, you figure it out. So I think in terms of operating satellites, there are some that they specifically targeted. But in the end, if Congress can appropriate, and Congress could put language into the appropriations bills that can accept what the administration is saying, defeat what the administration is saying, or say nothing. So with the satellites, some of that may be in the language or dragon. But things like if it involves air that you put down or sent to the storage, I don't think that it would be imposed. That would be more a matter of how does one try to do that, do the best you can with the hand that you dealt with the budget that you dealt with. And there are some things that one may have to look at in terms of, political considerations. Well, can we take it all out of one center, or do we have to sway the pain around? And that's I'm glad that I'm not in that position right now, but I have a lot of confidence in people who are in those positions to try to do the best thing that they can. But it's complicated and painful.
Yeah.
That was a great talk. Thank you for, I think, explaining just all different programs that NASA contributes to. So that was quite useful. I did have a similar question on that, but I'm going to go to a different which is with the current administration's cuts, especially if they continue within the next 3 to 4 years, do you think that NASA has the potential to reshape itself to create global cooperations and collaborations, just in terms of funding, where even though other countries might be less oriented towards the needs of US homes specifically, there's at least more diverse support for all of these programs to continue. And, you know, one example I can think of that's abroad is an organization like the European Center for Researchers, for example, which takes in a lot of like different countries, supports and collaborations for the program. So do you think a program like that should be developed within NASA in the next few years because of these cuts? Or do you think that's possible?
And, NASA does a lot in terms of integration, international kind of thing. The previous administration, and I think this administration still would brag about the number of countries that would sign the Ordinance Accords, so for for that program. But, there's always the sense of, how do we bring others in, but still be able to brag about it as our program. In earth science, there was a lot of work we worked with other agencies, primarily the usual suspects, if that moves up to Europe, Japan, Canada, but like the last big launch in NISA, Israel, so that Israel Space Research Organization. So that's the first major bilateral effort that we've had. The things with Argentina, Brazil, so it's actually a lot of that. And from a cooperation point of view, the things that we do with the certain space measurement networks, that we've done with the field campaigns, that's in some sense, earth science actually does more than a lot of the others do because they don't have as much in terms of campaigns and the field work. So, we've had the International Space Station, and with the Russian modules and the Canadian arm and various things from others. So, NASA has historically done a lot, but balanced with the political realities of China. We have NASA as a particular challenge of not being able to collaborate with China in any meaningful way. There's something called the Wolf Amendment based on Frank Wolf, who was a former congressman from Virginia, did claim certain things. So said one way we'll punish China was by limiting the ability of NASA to interact in any bilateral way with China. So Wolf has been dead for a long time, but then the agreement was on. So I mean, there are things, and China's launching like crazy, doing things that they had the first CO2 LiDAR in space, so probably the oldest CO2 LiDAR in space. We can't talk to them. If they presented at an international meeting, we can take pictures of their charts and try to get a sense of how they're doing, and that's not a limitation on say European colleagues. So they can do that. So we do pretty well, but we don't always talk about it that way, and we have to navigate certain politically, ways.
Josie.
Yeah.
Josie. So, there are these two groups here that have proposals in your former program, in the Earth observation to, coordinate between the satellites, ground truthing, and end member users that will use that information. So that program was, and there are probably only 40 applications, I don't know. Anyway, it was all supposed to be decided by June. Then they moved it to October decisions, and now they've said next year. So one, why didn't they just go ahead and fund things with the money that they had in the last budget? And then what's going to happen? Are they going to just say, forget it, and we're not going to fund anything? Or do we just keep hoping that something will happen?
I don't know. What I can say from my experience for a little bit is, the administration's budget proposal for FY26 is subject to units. And I think that average, the total 57% about for earth science, that would be spread you know, some way to go around the project at that time. So I think there is a sense of don't select for something that may not, you know, and you know, one of the things that you know, and of course, it's always fortunate because you know, historically, what we try to do is say, look, if we put out the most, you know, like that's that part of the community. And we really want to make sure those proposals get reviewed and we'll make decisions and do what we said we're gonna do. And I've been around for a long time, but you know, something like this is the magnitude of the changes of unprecedented. So I think that would serve this let's avoid doing the things that can until we're, you know, we have some confidence and might be like if somebody said, but even under the most dire scenario, you know, and you know, the Senate budget's a lot better than the administration proposal. The House budget's a little bit better than the NASA administration proposal. So, you know, if those things come along, you know, maybe a little bit better to bring things up, but my guess is what they don't want to do is say to somebody, you know, you're funded for potentially one thing might do is say, well, we can't actually select, but just select it, we'll forget a budget that will be in. But you know, that doesn't let somebody say bring on the graduate student. So it sort of goes for conservatism there because, you know, I was a program manager and you know, one of the you know, worst moments that I remember was like, you know, telling someone that they were funded and then having to go over them, the leaders and say, you know that before that I said that you'd be able to do. Back then, at least would be next year. You know, right now, with the cuts that are there, sort of trying to figure out how to juggle fiscal years and say, well, if you can't do it this year, we'll do it next year. You know, in an environment where you think that if their proposal becomes the basis for the future, next year is not likely to be any better. So that's where they end up, and my guess is everybody's really frustrated because you know the community responds to the solicitation with the expectation that we have you know this is unprecedented, and I think we all got expected that well the administration transition to most likely to be as good as it had been before. I don't know that people were expecting 57% up in their proposal. So you know, it's not to diminish the pain and frustration that's involved, because it's always worse on you know, for the people receiving it. But that's as much as I can say.
They're all sitting here. Well, as long as we can go to the ballroom and dance. That's
Maybe you'll be invited to it.
You had a question.
Yeah, I want to ask you about leadership. So you're a good example of good leadership matters. We were talking in the Swanson room this morning about wingnuts in Congress, and so having good leaders in the federal government is very important. I'm wondering if you can just comment for all the students in the room about the glory of leadership in the federal government. Make a case that there are great careers in government service.
Yeah, I think you know, some of this you have to think about, you know, what really motivates you and you know, what you're good at, what you like to do, and also, you know, where you want to be, you know, there's a variety of things. I'll sort of call it the breadth, depth, space. You know, in science, a lot of times, the way you get really, you know, known and recognized for the work that you do is being, you know, really good at a fairly narrow thing. You know, maybe considered the world's expert or something close to that. When you go into science management, you know, you're much more towards breadth. You know a little bit about a lot of things. But you know, you're not the expert on anything. You know, but you have that breadth. You know, one person's breadth will be another person's superficiality. So you know, have to, where are you comfortable being? What space you have, and then the other is really, do you want to be a doer, or do you want to be somebody who, on a good day, is the enabler? And my wife's a social worker, and she says, should be very careful how you use the term enabler, an enabler is usually not a positive thing, because the enabler is like, the person who bails out the bails the person out of prison 25 times or something. But, meaning that people have good ideas, and you can find ways to let them move forward with those ideas and implement them. Or, the early career investigator who writes their first proposal, and, it's right at the edge, and we said, yeah, let's go for that one. You're enabling things. Most of the time you don't get to enable, because in a statistical sense, you're saying no most of the time. But when you can, feel like the decisions that you've made are making a difference in the broader community, and it means they're getting to do things that they couldn't otherwise do. And in that case, we learn more about the earth, and ultimately that transmits to better products and services on behalf of society. That's a good feeling. So, I like doing that. I made that decision at a fairly early stage in my career. This one person we said, you did that too soon, Jack. You should have stayed longer. The opportunities don't come along that often, and sometimes you gotta decide what you're gonna do. So you have to think about it in terms of, am I a doer or am I an enabler? And am I, narrow and deep, or than shallow? And also, do I really just want to, be in the lab, or have my face in the computer, or do I want to be dealing with some of these other aspects? Do I want to have to actually worry about what's going on in Washington? Do I want to have to, work on reports that I may not really see a lot of value in, but the law says it has to be done, so I guess we have to do it. Those are all things that you have to think about, but, for me, I have a blast. I got to do a lot of fun things. I got a lot of joy out of the interagency and international work that I did. And I like to think that did that really well. I tried to create a culture for the staff of agencies. It's like someone will say, well, you have your day job, and then there's the interagency coordination. And I always tell people, interagency coordination is part of your day job. If you need to miss my staff meeting to go to an interagency meeting, go to the interagency meeting. You can always find out what happened at our staff meeting. Somebody's taking notes. So there's some of these things that you can do to try to encourage cooperation in a way that maybe people are less likely to be able to do. So, it worked really well for me. There's other people I think that you look back at in terms of, you see these people as real heroes, people who had vision, people who, made things happen that maybe would not otherwise have happened. But, if that's not for you, then maybe it's best to just do the things that, the more typical research scientists would do, whether it's at a university, a government laboratory, or, nonprofit or a private organization, because it's not a matter, this career good, that career bad. Try to find the best fit and do your best job, but I think recognizing that the community needs all of the above. I mean, the one thing I should say is, if you do the kind of thing that I did, stop being an active researcher, it's really hard to go back. And if I ever do that, it's like if somebody would say to me, go back to building a model. And I'd probably say, great, where's the key punch? So that I can work on it. And then so, Jack, you missed a few decades. So it's hard to go back. So that's something that you have to be comfortable with. But if you are, it would be great.
All right, thank you so much.